Hi. In this session, I'm going to talk to you about causal research design. This design is utilized when the problem is well structured. It's utilized when one is looking for a cause and effect relationship. Causal research design is one of the three primary data gathering research designs. The other two are exploratory and descriptive research designs. When the goal is specifically to find out a clearly defined cause and effect relationship, causal research design is called for. In this session, we'll examine causality, what an experiment is, look at a few examples, and then identify some experimental designs. A causal research design is used when one is interested in examining a causal relationship amongst variables. Other terms used to describe a causal research design are experiment, A/B tests, and randomized control trial. Depending on the context or industry you're in, you might hear different terminology being used. Many folks in marketing like calling it an A/B test, while those in the pharmaceutical industry like calling it a randomized control trial. Now let's take a look at what the concept of causality is. We often talk about X causing Y or A causing B, but what does it mean from a scientific perspective? More specifically, let's understand what are the requirements to conclude that X causes Y. The three requirements for causality. One of them is correlation, also formerly known as concomitant variation. When change in X is accompanied with change in Y. In other words, when X goes up, does Y go up or down? The second is temporal ordering. In order for X to cause Y, X must occur before Y. The third one is perhaps the hardest one to establish, which is ruling out all other plausible explanations. If X goes up and Y goes up, X may still be occurring before Y, but Y could be going up for a whole host of reasons other than X. Ruling out those other possibilities is the goal of the requirement of the third condition for causality. Let's understand this using an example here. When changes in one variable correspond to changes in another, we have correlation, also known as concomitant variation. In this example, in this fictitious example, a coffee shop owner does a little bit of a test. He decides to have only 4 types of coffee beans in his store. And he notices when he has 4 types of coffee beans, his sales are $5,000. When he increases the number of coffee beans offered in the store, his sales go up to $6,000. When he increases the number of options available to 12, sales move even higher, and at about 20 different types of coffee beans, his sales jump to $7,000 in daily sales. This is an example of concomitant variation or correlation. As coffee variety goes up, sales go up, although not linearly. The fact that the variety of coffee beans is tied to sales indicates the first condition of causality in this case has been met. Coffee beans is related to or correlated with daily sales. Now, it's important to remember that correlation itself does not imply causation. It's a necessary but not sufficient condition for causality. There are a number of interesting examples in the literature that highlight this distinction. One of the common ones is that correlation, number of police officers, and number of crimes. For instance, there's evidence that indicates that the more number of police officers there are, the more number of crimes there are. It would be foolhardy to assume that police officers are causing crimes. On the other hand, it might be reasonable to imagine that when there are a number of crimes occurring in an area, more police officers are sent to the area. Another example in the literature is that the amount of ice cream sold and deaths by drowning have been found to be highly correlated. Now, I'm hoping eating ice cream isn't leading to deaths by drowning, but they're correlated. Now, if you think, you may very quickly realize that there's a common factor here, that the times when ice cream is sold or when ice cream sales are up, usually the weather is warm. When the weather is warm, people tend to swim a lot. Well, so it's not the ice cream that's causing deaths by drowning. It's probably the fact that it's warm weather that's encouraging people to eat ice cream and also go swimming. If more people jump in the water, you'd expect that quite naturally deaths, unfortunately, might go up. There's actually a nice website here by Television where he talks about spurious correlation. Let me try and pull that up here. In this website, he talks about a number of examples of spurious correlations. A spurious correlation is one where, let's get to the screen first, excuse me, where you've got a correlation that is not meaningful. So for example, here are two lines indicating the trends for suicides by hanging, strangulation, and suffocation in US spending on science, space, and technology. The correlation here is 0.9978, so on and so forth. It's a really high correlation, given that the highest value for correlation is 1. Now, again, it'd be foolhardy to assume that the more America spends on science, space, and technology, the more US spending on science, space, and technology is causing suicides by hanging, strangulation, and suffocation. That would be just, foolish. It would be just as foolish to assume here that that the more movies that Nicolas Cage appears in, the more number of people drown by falling into the pool, just because there is a correlation between those two numbers, sets of data. Correlation of 0.666. Okay, so we understand then that correlation is not the same as causation. Right? Here's one more example here. As you can see in the right in the little bar chart, you can see the green bars indicate the market share for the browser Internet Explorer that is no longer available, or I don't think it's available anymore. And there's a blue line indicating murders in the US. Again, strong correlation out there between IE market share and murder rate. I don't think one is causing the other, or it would not be reasonable to assume that. So just because two quantities are correlated doesn't mean that there has to be causation out there. It is possible though, but not a guarantee. Okay, let's move along here to a little bit of humor. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. Hopefully that made sense to you in light of the contrast of correlation and causation. The second requirement for establishing causation is a temporal ordering. The fact that in order for X to affect Y, X must occur before Y. So correlation is a bidirectional relationship, while causation has a clearly defined direction. It goes from one to the other. In the example I just showed you about coffee variety and sales, one must ask the question then, did offering more types of coffee beans lead to greater sales? Or is it that there were more sales that prompted the store to expand the offering of coffee beans? The only way to know what affected, what is to know which of the two occurred earlier. The one that occurred earlier is the only one that can be the cause. Now, that being said, there are typically so many different things that might move the needle. For instance, example of sales of this fictitious coffee shop. Many different things might drive daily sales at this coffee shop, other than the variable of interest. So while we're focusing here on coffee bean variety, it may just easily be possible that sales are going up or down because of the weather. Maybe warmer weather got people to come out more, and that led to them visiting the store more. It could be a vacation effect. It could be a day of week effect. It could be an ad campaign. It could be a competitor store closing down. Bottom line, there can be a number of other possible explanations other than coffee variety that might be boosting sales for this coffee shop. The only sure way to control for all other plausible explanations is to conduct an experiment. What an experiment does is it artificially controls for the effects of all other variables. Okay? In a sense, it's going to change one thing and only one thing and not let anything else change. This way we can isolate the effect of coffee variety on sales and see if that effect is indeed present or not. So an experiment is the way to accomplish, is the way to rule out other plausible explanations. As Mosteller and Tukey said quite wisely, the only way to find out what will happen when a complex system is disturbed is to disturb the system, not merely observe it passively. There's a subtle kind of undertone here of them taking a crack at surveys here. If you think back to the descriptive research design or exploratory designs, they involve somewhat passive observation rather than modifying or disturbing the system, as Mosteller and Tukey put it. Disturbing the system involves manipulating a variable. Okay? We'll see more about that in this next slide. So disturbing the system involves manipulating a factor. This is essentially involves creating a treatment or an experimental manipulation. We take a variable of interest and modify it to be off and on, or off, on, and very much on, let's say. Okay, so these different levels are what we're going to compare. Right? So the variable of interest will be manipulated to have many different levels. The second requirement for an experiment is to have an outcome variable, something we're going to measure. So we can compare when we have the switch off versus on, how does something else vary? That something else is the outcome variable, the effect we're gonna measure. The third element is random assignment. To control for other plausible explanations, essentially to control and keep everything else constant, we do what is called random assignment of the subjects. And to ensure external validity or generalizability to findings, we typically utilize a random sample. Let's take a look at an illustration then of how one could conduct a lab experiment to examine the effect of a variety of coffee beans on sales. Let's imagine we decide to create a random sample of 90 coffee drinkers by randomly choosing people from a large, let's say, population or sampling frame of coffee drinkers. The next step would be to split this group of 90 coffee drinkers into 3 groups randomly, so that any given coffee drinker has an equal chance of being in group 1, 2, or 3. The next step would be to manipulate the variable of interest. In our particular instance, the variable we're examining or trying to manipulate is variety of coffee beans. In other words, we're interested in seeing if different coffee beans lead to different sales or not. So we're going to create variations of coffee beans. So one way we can do this is in our lab experiment, our kind of contrived environment, we will show 30 people a menu with 4 types of coffee beans. And then we'll show another, remember we have 90 people originally, so we have 3 groups of 30, 30, and 30. To our second group, we will show a menu with 8 types of coffee beans. And to our third group, show a menu with 12 types of coffee beans. Here we have manipulated the variable coffee beans at 4, 8, and 12. Now, one could argue that, the sales can be affected by, I don't know, weather. But bear in mind, this experiment is being conducted at the same time in the same place. So what is controlled for? One could argue that, maybe there's a gender effect that men don't care about variety, women like to have a huge menu of options. Well, since our group was created using random assignment, all 3 groups of 30 respondents would be expected to be very similar. Every individual had an equal chance of being in group 1, 2, or 3. And therefore, they should be similar. Therefore, random assignment has enabled us to control for all other plausible explanations. Our next step is to measure the outcome variable. So we'll ask them now, they've seen the menu of coffee beans, their intention to buy coffee beans. We'll ask the next 30 people the same question, and the last 30, the same question. Ultimately, we're going to have three measures. One for intention to buy coffee beans for group 1, 2, and 3. To sum up then, what we've done here is we had a random sample of 90 coffee drinkers. We randomly assigned them to one of 3 groups. We manipulated the variable of interest, variety of coffee beans at 3 levels, 4, 8, and 12. And lastly, we had an outcome variable called intention to buy coffee beans that we're measuring. Now, this is the structure of an experiment. Now, some would argue that this is kind of contrived, in that we showed a menu with 4 types of coffee beans to some people. We're expecting that to affect their intention to buy coffee beans. These are, not real sort of scenarios. I mean, people seeing coffee beans in a store to choose from in bags is different from looking at a menu alone. Actually buying coffee is different from expressing intention to buy in a 1 to 5 scale. To that extent, this experiment is a lab experiment. It's contrived. It's not as real. An alternative is to conduct a field experiment. Now, field experiment has its own problems, but let's highlight the benefits first. But before that, let's examine how this will be structured. Based on the structure, except now we can't draw a random sample, we'll just take customers of coffee shop. So we'll look at all the customers in the coffee shop, and what we'll do is when people come in, depending on which week they come in, they'll see a different menu. So our random assignment is happening based on 3 weeks. We're assigning week 1 as sort of like our group 1, week 2, group 2, week 3, group 3. The underlying assumption here is that people coming to the coffee shop are fairly similar across the 3 weeks. They're no different. It might be a bit of a stretch, but that's what we got to do in a field experiment. And then in week 1, we have a menu with 4 types of coffee beans. In week 2, we've got a menu with 8 types of coffee beans and 12 for week 3. The sample for each of the 3 weeks will be week 1 customers, week 2 customers, week 3 customers. So we've done the first 3 things out here. We did random sample, then we did random assignment, and third, we examined the factor with 2 or more levels. Lastly, we measure sales of coffee beans. We examine, again, how much money is generated at the cash register every week. So we have a real measure of sales here, and real menus being given, and real choices being made by people. To that extent, a field experiment represents, it more closely mirrors reality than does a lab experiment. Of course, there are a couple of downsides out here. In trying to create a scenario or, trying to mimic reality, we have unfortunately, made some big assumptions out here. One of them being, the big one being that we are assuming that customers in week 1, 2, and 3 are all more or less the same. Might be, but we can't be sure. We're also assuming that week 1 customers don't come in week 2 and week 3 also, right? So you might have a bit of the same customer coming 3 different weeks. You might have carryover effects. People who've seen the menu in week 1 might react to week 2's menu. So there might be an effect of, how people are thinking about having seen a different menu over week 1, week 2, week 3. There are lots of other threats to validity of this experiment then. Bottom line, an experiment is a great way to rule out other plausible explanations. The big choice is, of course, whether to do a lab experiment or field experiment. Both have their own challenges. There's a really good video here on YouTube that you can watch, where some really renowned experts in experimentation shared their views on the benefits and failings of each of these kinds of experiments. Okay, so internal validity has got to do with problems with the actual effect. How well have we established an effect? External validity has got to do with how generalizable are findings. Okay, so you can now that you've got a sense of how an experiment works, you can try and think about putting together your own experiment to examine something like coffee quality and sales, or in-store atmosphere on customer satisfaction. Or you can think of an experiment to examine the effect of price on perceptions of brand image. It's not too hard. So try those out. Let's move along now to another example of an experiment. This one is derived from a study done by Gavin Fitzsimons. It's a very interesting study, but let me see if I can pull up a short video here so he can tell you how the study works. Actually, I'll let you watch that video on your own. So that link will take you to a short video where Gavin talks about the motivation of his idea. I'll give you the short version of the idea. The idea is that when you go shopping in a store, you frequently put a lot of things in your shopping cart. Some products are, edible, some are not edible, some are yummy, some are ew or disgusting. So imagine your shopping cart might have things like kitty litter or along, and you may also have baby food. You might have bleach, and you might have let's say a box of Nutella, right? So in a sense, your shopping cart can have all these different disparate items, and one might feel like certain items are sort of not good or not clean or not desirable. So could somehow the undesirable or disgusting properties of one product rub off onto another product? Like, could your Nutella bottle be somehow tainted now that it's been in contact with a bottle of bleach? Now, clearly, this is totally psychological. It's not real. Bleach cannot flow out of the box or bottle it's sealed in and packed into and go into your bottle of Nutella. That cannot happen. However, in our heads, this might happen. So you might devalue Nutella because it's in contact with bleach, for example. So Gavin and his team decided to pursue this idea by conducting an experiment. Here's how they went about it. The first thing they did was they had to establish a factor, a variable they're going to manipulate. In their case, the manipulation was done by distinguishing whether the disgusting product, the quote unquote disgusting product, was in contact with the desirable product or not. In one case, it was touching. In one case, it was not touching. They measured the outcome as how much would you like to use the product. The setup looks like this. They decided to recruit a whole bunch of Duke University students. Think about 60 of them. And when they arrived at the experiment place, they were told to go to either classroom 1 or classroom 2. Assignment to the 2 classrooms was done randomly. So each student had an equal chance of going to classroom 1 or classroom 2. For this reason, you'd expect the students in either classroom to be similar based on demographics, their preferences for cookies, and so on and so forth. A shopping cart was parked in the front of each classroom. In one classroom, the shopping cart contained Stay Free, Tide, Cheerios, and cookies. In the other classroom, it contained the same products. You're probably wondering, well, what's the difference? The difference is touch or no touch. Stay Free was marked as being the quote unquote disgusting product. The product of interest was cookies, was a box of cookies. In one classroom, Stay Free was in contact with the cookies. In another classroom, the shopping cart, they were set far apart. Students were asked, amongst many other questions, a question about how much would you like to use this product? And here's what they found. They found that, excuse me, I mentioned earlier incorrectly that there were 30 and 30 in each classroom. There are 46 and 46 in each classroom. So pardon me for that. The reading of cookies, the box of cookies for the touch condition was 5.47. Here, a higher number means more likability or more liking for cookies. So when cookies were touching the box of Cheerio, a box of, Stay Free, cookies were rated as being less than when they're not in contact. This difference was found to be statistically significant. In other words, Gavin's team then established that touching somehow makes the products less desirable, makes the desirable product, less likable. In other words, product contagion is real. Now, one could argue that, or Gavin's team wanted to dig deeper to understand what is it about Stay Free that made the cookies less desirable. So decided to manipulate not just one factor, but 2 factors. This is quite realistic. In most cases, we don't just change 1 or 2, just changes one thing. We often want to change 2, 3, 4, 5, 6 things. So they've gone with changing 2 things. They examined the role of touch and no touch or contact. They also decided to examine the effects of one more product. So what is it about Stay Free? Well, because it's not desirable, maybe. They took another undesirable product. Nobody likes doing taxes. So they had a box of TurboTax software. They had a CD and DVD and so on in that. They decided to use that as their second product. So now they have 4 combinations possible. Stay Free, touching cookies. Stay Free, not touching cookies. TurboTax touching cookies. TurboTax not touching cookies. The setup is very similar to last time. So they still have the shopping cart parked in front of the classroom, and then they have these 4 possible combinations. Since we have 4 conditions, we have to have 4 classrooms. In other words, the sample of students coming to participate in the study now have to be assigned to not 2 groups, but 4 groups. So with 2 factors, each factor with 2 levels, we end up with 4 different groups. Here's what it looks like then. We have now 4 conditions with a sample size of 48 in each, with combinations of state-free touch, no touch, looking as follows. They went ahead then and examined the results. Here's what they found. They found that when state-free was touching cookies, they were rated as being 5.71. That's not liked. And they found that people don't like it. But when state-free was not touching cookies, they liked it. Now, when they examined the same exact contrast for TurboTax, they found out that these 2 differences are not statistically significant. In fact, they're in the opposite direction, but they're not significant. So they're approximately equal then. So what they ultimately concluded with this finding was that this product contagion only applies to state-free, not to TurboTax. In other words, somehow the undesirability of the cookies was only attributable to 1 product, state-free, but not to TurboTax. This is also known as an interaction effect. If you were to graph this, it would look like this, or with a bar chart, it would look like this. So for state-free, the red bar and blue bar are different, but not so for TurboTax. This is called an interaction effect. We'll look at this in much more detail in a couple of sessions. Okay, so let's talk a bit about experiments not with Duke University students or in a university campus alone. Experiments are conducted and practiced a lot, and it's just we don't hear about them a lot, but they're conducted very widely. I'll give you an example of Google a couple of years ago was trying to figure out whether which of a couple of possible combinations of to use for its YouTube sign-up page. They're looking at very subtle variations in the sign-up page. They want to know whether they should say sign up. The word sign up should be in all title case or all uppercase. The background should have been one of 4 backgrounds, and a few other such subtle things. And when they put it all together, they realize they have 1,024 possible combinations of these subtle changes to the YouTube homepage. They conducted the experiment. Their outcome variable was the percentage of people coming to the page that sign up or register for a YouTube account. Ultimately, using this experiment, they were able to pin it down to 1 possible design that worked best for them. Many companies will frequently use Google's website optimizer for figuring out the best way to design their website. A very simple example could be a website owner could create 100 different variations of their site and then compare some metric that tells them whether the site has met its goals or not. This could be how much time somebody spends on the site, the percentage of people that bounce from the site, or if somebody made a purchase from the site. Based on this, the website owner would then figure out which design is yielding them the most of their goal and go with that one. Google Analytics allows people to conduct A/B tests on their websites all the time. And here's another interesting study done by a couple of years ago by Kramer and others, published in the Proceedings of National Academy of Sciences. In this study, the authors were curious to know whether emotional contagion occurs on Facebook. We already know this happens in the real world, right? Give an example. You've probably caught yourself smiling when you saw somebody else smiling. There's a reason they have this laughter they impose in the background of some TV shows, because they know that if you hear other people laughing, you're going to want to laugh as well. So we know emotions they're contagious in the real world, and it works on TV also. Well, the authors of the paper were curious to know if emotions are contagious over social media as well. In other words, if your friends on Facebook are saying good or happy things, would that make you happy? If your friends on Facebook are downbeat or depressed, would that make you feel the same? For this purpose, the authors conducted a large-scale field experiment. About 200,000 people were chosen for the study. For 100,000 or so people, their newsfeed was modified to include positive and neutral messages only. For another 100,000, their existing newsfeed was modified to only contain negative and neutral messages. Now, as a sidebar, you all probably know that you don't see all the messages in your newsfeed. You see about 2 to 5% of all the messages in your newsfeed. The choice of which ones you view is made by Facebook. So in this case, experimenters artificially doctored the news feeds so that one group saw positive and neutral messages, the other group saw negative and neutral messages in the newsfeed. Then they monitored what those people were posting on their own. They noticed that people who had their newsfeed modified to be positive and neutral messages tended to post things that are more positive, upbeat, and happy. On the other hand, the group whose newsfeed had been doctored to be negative and neutral were posting more negative, sad, and depressing things in their Facebook posts. This led them to conclude that emotions are indeed transmitted over Facebook as well. You can read more about the paper here, or you can Google for the study. Facebook got a lot of grief after this study happened for conducting this experiment, or allowing. There's a similar study by OkCupid where they're trying to figure out whether their matchmaking algorithm works or not. They test this out by having a placebo group and an experimental group. So an experimental group was the algorithm they came up with to match people up with their dates. And the placebo or control group was a random matching of people. So OkCupid is a dating site, if you don't know that. OkCupid tries to match people up. They came up with an algorithm to match people up. And they want to see if the algorithm worked or not. So half the people were matched up by using the new algorithm. The other half were matched up randomly. And OkCupid monitored how their dates went based on whether they continued seeing the person they were matched up with. It turned out, OkCupid found out, their algorithm did much better at ensuring second dates than did the random matching. This led them to conclude their algorithm worked. Of course, as you would imagine, the experiment, or the story of the experiment, leaked out as I found out about it. And they had a huge public backlash for conducting such an experiment. Especially those in the control group were pretty upset that they're being randomly matched up and sent on dates as part of an experiment. Okay. So here's yet another example. The Obama campaign conducted an experiment to figure out, again, which website they should go with here. And so we have here 30 variations. What they did was they examined the sign-up rates of these 3 different variations of the site to figure out which pictures to have on the page. And so you probably know that the third one was the chosen one after the experiment. They also spent a lot of money on figuring out subtle things like, the button to use for signing up again. So you can do sort of very, very micro-specific experiments using these web tools. Now, we by now you've probably got a pretty good idea of what an experiment is and why to conduct an experiment. I'm going to review here a couple of different experimental designs. My goal here is not to go into too much detail, but to give you just enough to have a working understanding of the various designs available. So bear in mind, an experiment involves 4 things: a factor to be manipulated, a process for distributing test units across levels of factors called random assignment, an outcome variable to be measured, and a method for controlling extraneous variables. That's basically what your experimental designs experiment involves. There are 4 kinds of designs available then: pre-experimental, true experimental, quasi-experimental, and statistical. A pre-experimental design is not really an experimental design, hence pre-experimental. The only real experimental design out here that meets all the conditions of an experiment are true experimental designs. Amongst these are pre-test, post-test, and post-test only control group type designs and solvent for group. There are quasi-experimental designs that try to mimic, or they try to address all the requirements of an experimental design, but they fail in some ways. Then there are statistical designs that are designed based on some specific structure in mind, like a factorial design or randomized block design. Okay, so these are detailed in the slides here that I'm not going to go into in any more detail in the interest of time. To wrap up then, we've examined here the conditions for causality and then looked at ingredients of an experiment and example, and very quickly reviewed the various ways of constructing an experiment called an experimental design. Thank you.